Ciao friends! In this session, I want to work with you on a budgeting solution using Power BI. Here is the scenario. Contoso already has a Power BI model that is useful in order to analyze the sales. We are at the end of 2009 and we want to integrate inside the existing Power BI model a budgeting information. So we have an Excel file containing the figures for the next year, 2010, and we want to merge this information inside the data warehouse in order to do further processing. We will start from the raw data and we will integrate everything inside Power BI. In the process of doing all these steps, we will face several issues, several problems that we will need to solve. The final takeaway of the session is not how to compute a complete budgeting solution. That is up to you, because when it comes to budgeting, each company is a story by itself. Instead, I want to show you how you can leverage DAX in order to build complex solutions and obtain great results. Follow me. The start is this Excel file. As I said, we have Contoso. Contoso has its own Power BI model, but they want to integrate this budgeting information. Now, the budget information contains not very detailed information. It contains just rough figures. So we say that in China, for a datum, we have three different scenarios: low, medium, and high. Low says that we sell $171,000. Medium is a bit higher, and the high is definitely much higher. And the granularity of the information is at the country region and at the brand. So we have three countries: China, Germany, and United States, and this set of different brands. So as you see, we do not have information for each individual product. We do not have information about time. We don't know when sales will happen, and we don't have very detailed information. We just have a rough figure. We want to integrate this information in Power BI. Now, I already created the table in Power BI. You see that we have this table containing country, brand. The only thing that I already did is that I unpivot the scenario. So instead of having it in the columns, we now have it on the rows. So China, a datum, the scenario, and the budget value. We can use this information to slice and dice exactly as I'm doing here. So I created already a matrix that is showing country, region, the brand, and a slicer. Let me select the different values for the budget. The problem appears as soon as I start to integrate sales into this model, because the model already contains information about sales. So if I want to compare the budget with the sales in the previous year, I have a measure, sales in 2009, that computes the sales for 2009. But if I put this measure in my matrix, you see that the numbers are not exciting. It is showing the same value everywhere. The reason is that I created the table budget, but I have not created any relationship with the remaining tables in the model. The model contains sales, customer, date, and product. But there is no relationship between budget and date. There is no relationship between budget and customer, and same with product. That's why when I try to slice by country region from the budget table and I look at sales, I have always the same number. And the scenario is not going to be different if instead of using columns from the budget table, I get rid of the brand and the country region, I can use the country region from the customer. Now the scenario is different because country region from customer slices sales correctly, but it does not slice in any way the budget. Now budget shows always the same value. So the first problem that we need to solve is to build the set of relationships, a correct set of relationships between the budget table and the remaining tables in the model. We have several options of doing that, and we will see them one by one. Before moving further, let's look at the tables that we need to link. We have customer, we have date, and we have product. We will use three different techniques for the three tables. We have, as you have seen, we cannot slice by country, we cannot slice by product brand. The brand is one of the columns in the product table, and if I try to slice by product brand, I have the same scenario. And again, I cannot slice by month. Month slices sales correctly, but it does not slice the sum of budget. If we look at more details, when it comes to customer, we have actually the country region column. Country region is present in budget and it's also present here in customer. In a similar way for product, we have the brand column in the budget table and we have the brand in the product table. So we will be able to use these columns in order to build a relationship. But when it comes to the date, if I want to slice by month, then I'm definitely in trouble because data contains the month number and the month. Budget has no information at all about when sales happened. If we look again at the budget data, you see that we do not have any information about the time. We need to solve the three scenarios one by one, and we start by solving the scenario with the month, just because it's the first one that we have on the screen. Now, think about that. How can I create a relationship between the budget table that does not contain any information about data and the date? What I need to do is to provide information about dates in the budget table. I can put the year, I have multiple options. The option that I'm going to choose is to increase the number of rows in the budget table. So instead of having this structure, where we only have country, region, and brand, I want to add one column to the table that contains the month number. By increasing the number of columns, the value of 231, that is the budget high for a datum in China, will become 12 different rows. So I'm increasing the number of rows in the table. If I increase the number of rows, I need to guarantee that the total, so the sum of the budget, is still the same. So I will increase the number of rows, but I need to divide the value of the budget by some number in order to obtain still the same total, even though it will be split month by month. To do that, I have several options. I could just divide the total by 12. So I have 12,000, let's say for 2010, I divide it by 12 and I put 1,000 for each month. But by doing that, I'm not actually computing correct values or values that have a good meaning, because I'm assuming that sales will happen every month the same. It's not the case. Contoso does not have such a precise division of sales. What I want to do instead is follow the pattern of sales of the previous year and slice sales by month following the same pattern. That's why I built a report, sales distribution, that shows the distribution of sales over time. Now, numbers are hard to read, but we can zoom in a bit. You see that what I'm projecting here is by country and by brand, by month, the value of sales in 2009. And you can see that there is a clear pattern that depends on the country and on the brand. If you look at China, for example, in January they sell something. In February, it looks like they are not buying anything at all. In March, they start buying again. And in April, they start buying as if there were no tomorrow. Then in May, goes back to a regular value of sales. And in June, sales start again. But this is for China. If we look at Germany, things are different. In Germany, sales are much more regular in the first month, and still we have this peak in April. If we look at United States, again, a different pattern. So sales are completely different depending on the brand and depending on the country region. If I want to use this information to allocate sales by month, what I need to do is transform this, that is actually now a report, into a table that contains the percentage of sales of every month and use it to multiply the value of the budget. So I create a table that says, well, in China, in January, for a datum, you need to allocate 3% of the total sales of China a datum. To do that, I need to write a query and then create a table. So the first step is to take this report that is slicing by country region, brand, and month, and transform it into a calculated table that contains the percentage. I need to write quite a lot of DAX code. That's why it's now time to open DAX Studio and start writing some code. So let me open DAX Studio, move it there, and we have DAX Studio ready here. We also make some space because the code will be kind of long. So what we need to do is group by sales, by country region and brand. So we start writing evaluate. We want to summarize sales by product brand, and by customer. I don't need that. Country region. I can start running this first query. Let's zoom in a bit. And this returns the different brands and the different country region. Then I need to add the sales amount. Oh, I also need the month number, so I want the brand, the country region, and I also want the date, month number. Now I have Contoso, United States, the month number. I need to add sales to it, so we use add columns around it, and we create a new column, sales amount, that computes the value of sales amount. Run the query, and now we have Contoso, United States, in January. This is the value of the sales amount. It's always a good practice to check that the numbers we are looking at are actually correct. So we can go, let's take Contoso, United States, January. Look here, and we have Contoso, United States, January. It's 395. So the numbers we have computed there, which is 1.4 million, is wrong. The reason is I forgot to compute the sales for only 2009. This is the sales amount over all time. So because the entire calculation need to be for 2009, I add a filter that says that the date calendar year need to be equal 2009. Run the query again, and we have 395, which is the expected result. Now, this is the sales amount. So basically what I did so far is recreating the same report that we had in the matrix. But I am not interested in the sales amount. I want the sales amount, and I also want the grand total of sales amount, which is the number here. So for United States, Contoso, right now I'm computing this value, but I want to compute this value, 7268, because I want to divide 395 by the total to transform that into a percentage. So we need to add a new column here, which is the yearly sales. And to compute the yearly sales, what I need to do is get rid of the filter on the month, keep the filter on the brand and country region, so to compute the total sales for all the months. That is where calculate is useful. That will be calculate sales amount, and we'll remove the filter from the date, month number. If I did it correctly, now we have sales amount and yearly sales 7268, which is the correct number. Let's check it. That is 7268. So we have the correct value, and we can move further. If you think about that, I'm not interested at all, neither in the sales amount nor in the yearly sales. These two numbers are only useful in order to divide one by the other, because I'm interested in the percentage of Contoso, United States, January over the total. So instead of computing the sales amount, I can compute the percentage by dividing sales amount by the value of yearly sales. Now I no longer have the values. I can run the query. That becomes a percentage, and you see that it is telling me that Contoso, United States, in January should allocate 5.44% of the yearly sales. That is the first number. So now we have a percentage. What we need to do is multiply this percentage for the budget of Contoso, United States, that contains the value of the yearly budget. This requires a bit of reasoning, because if we look at the budget data, in order to obtain the value for Contoso, United States, let me sort by country region, or actually by brand is probably easier. We search for Contoso, United States. You see, Contoso, United States allocates 6 millions in the high scenario, 4.5 millions in the low scenario, and 5.3 millions in the medium scenario. So I have three different values for Contoso, United States. In order to obtain one value only, I need to provide the country region, the brand, and the scenario. At that point, I can use a lookup value to grab the value and do the multiplication. Let's do that with the query. I need to reduce the font a bit, because now I have my percentage. I need to have the budget information. As I said, we can use lookup value, and we need to provide the country region, the brand, and the scenario. So I can use lookup value and search for the budget brand. The font is a bit too small. Okay. I want the value of the budget, where the budget brand is equal to, I can use product brand, because add columns is iterating over a table containing the budget brand, so the product brand, and I can use the value right here. And I can do the same for the budget country region. That contains the customer country region. But if I want to obtain a number, I also need to provide a value for the budget scenario. Let me just write low for now. We will fix that later, because I want to run the query and see that I actually have the value for Contoso, United States low. If I run it now, you see that I have the brand, the country region, the percentage, and the budget 4510. That should be Contoso, United States low. As we always do, let's check it. Contoso, United States low is 4510. That is correct. Next step is that I do not want to hard code low inside my query. I need it to be data driven. So what I need to do is add to the result of this summarize the values of the budget scenario. And we do have three values for the budget scenario. So I need to add it to the result of summarize, and cross-join is the function that will help us do that. I cross-join this entire result with the values of budget country region. Now that I have budget country region in the row context, I can replace this low with, oh sorry, that's not budget country region, budget scenario. Okay, I can take the budget scenario from here and use it here. Now, I totally know that this code budget scenario equals budget scenario looks actually really weird. The thing is, this is the column I'm searching into, so I'm declaring the column that I search into, and this is the value I'm searching for. So this budget scenario is evaluating the row context created by add columns over the cross join, and this is a column reference that declares the column that I'm searching into. So despite being the very same code, they are two different purposes and they are used in different ways. If I did it correctly, now I should have the scenario here. You see, I have a new column with the scenario. The value for the budget is still correct, but if we go for different scenarios, we should find medium. You see that we have different values for the budget. And near the end, we should also have high. So now this query is computing the percentage and the budget. As it happened earlier, we are not interested neither in the percentage nor in the budget. We want these two values only because we want to multiply them one by the other. So instead of computing the percentage, I can compute the allocated budget that simply multiplies one by the other. And if I run the query now, the result contains brand, country, region, the month number, the scenario, and the value of the allocated budget, which is the final goal that I wanted. I can now take this code and create a table in the model. But remember that the purpose, the reason why we created this table was to build a relationship with the date table. And we are still missing a date in the result. The result that we have so far contains the month number, but it does not contain a date. That is not a big problem because we can link the budget to the first day of the month. So we can create a date column where we use date. The year is 2010 because that is the year for which we are creating the budget. Then we take the month number for the month from the current row context, and for the day we just use 1, the first day of the month. If I run the query now, you see that we have the brand, country, region, month number. We are not going to use the month number. Instead, we are going to use the date column to create the relationship. I can now copy this entire code, go back to Power BI, and create a new table. We call it allocated budget, and I copy the entire piece of code. So this is the same expression I wrote in DAX Studio. Just hit enter. We check that the table is indeed there. We have the allocated budget table. And you see the same content that we had in DAX Studio is now available in Power BI. Next step is to build a relationship. I need to take the allocated budget. I can put budget away because I'm not going to use it anymore. And build the relationship between date and date. Unfortunately, it does not work. And I have a circular dependency error. Now, this is nothing to be scared of. Circular dependencies typically happens whenever you reference the blank row inside the expression you write. We have a video that describes that. We have articles, so if you are not familiar with the concept of blank row, you can go there and take a look. What we need to do is go in our code and remove any reference from the blank row. So if we find all, we need to get rid of it. If we find values, we need to get rid of it. Here we're using values of budget scenario. We need to use distinct of budget scenario. Or actually, we could use all no blank row, which is even better. Because there is no filter, so the two would return the same value. Here we're using remove filters, so that is not a problem. Lookup value is not a problem. We still have a problem with this calculate. Remember that filter arguments of calculate are actually expanded. This becomes a filter all date calendar year, where calendar year equals 2009. And now it is more evident the presence of all. We never want all, we always want to use all no blank row in order to get rid of any dependency from the blank row. And if I did everything correctly, now I can copy this code, go back to Power BI, replace the code with the new version, content is the very same, but if I did everything correctly, now you see I can build the relationship between date and the allocated budget table. Doing it this way, now let me get rid of it. I can go in my report and start to make it work slightly better. Let me gain some space. Now I need to do some work because right now the columns here are using the budget table, and instead I need to use the allocated budget table. So on the slicer, instead of having the scenario by budget, I need to put the scenario of the allocated budget. And here, instead of having sum of budget, I need to put the allocated budget value. Sum of budget can disappear. Now I have the month coming from the date, I have sales, and I have the allocated budget that changes depending on the scenario. So this is already a first goal. By changing the granularity of the table, by increasing the number of rows in the table, we have been able to build a relationship between the budget and the date table. That is a first technique that you can use. We have done everything in DAX. You can use Power Query, you can use whatever tool, but increasing the number of rows is always a good practice if you need to allocate values. We had to find a good weight in order to allocate values the right way and not just divide by 12. But we have other options to build this relationship that we are going to use for the next tables. Because we have a similar problem, we have solved for data, we have a similar problem with customer and with product. Let's focus on customer. How can I build a relationship between the new table allocated budget and customer that needs to be based on the country region? Country region is a column both in customer and in the allocated budget table, but it is not a key in the customer table. So if I want to build a relationship, one option is to create a table here. So I will build an intermediate table here that contains the values of the country region. So country region will be a key for that table, and I will use it to slice both customer and allocated budget. Creating this table is much simpler because it only needs to contain the distinct values of the country region. So we don't need DAX Studio to do that. We can just go there and build straight a table. Let's call it the country region. I can use, we can go for all no blank row of customer country region. And that returns the different values of customer country region. If we want to really be precise, we cannot just use customer country region. We need to merge it with the values of country region coming from the allocated budget table, so that if a country, for whatever reason, is present in one table and not in the other one, appears in the result. So I can union this with all no blank row of we can use budget country region. Now, the problem of doing that is that now you see country region as duplicated. That is totally expected because union does a union all, but I can run a distinct later in order to get rid of duplicates. And now I have my table containing the different country region, either coming from budget or coming from the customer table. The table is here, and I can now use this table to build the relationship. So customer country region goes to country region, and the allocated budget country region goes to country region. Now country region, because it's on the one side of a relationship with both customer and allocated budget, is able to slice both customer and allocated budget. Let's give that a try. I need to remove the month, and instead I take the country region from country region, drop it here, And you see that it is slicing by country region, and I can see sales and budget correctly sliced by country region. The only thing I need to pay attention to is that I need to use the country region from the country region table. If I use the customer country region, which I have here, customer country region slices sales, but it does not slice the budget. And the reason is customer country region is here. A filter from customer will not reach country region, therefore it will not reach budget. If I use a column from this table, I will be able to slice budget, but if I use a column from customers, I will not. If I want to use a column from customer, I could do a trick, which is dangerous, but in this case is useful, that is enabled by directional cross filter on this relationship only. If I enable bidirectional cross filter on this relationship, now customer will filter country region will filter budget. And if I go to the report, now this country region is the country region coming from the customer, but it is slicing budget correctly. You always need to ask yourself before using bidirectional cross filter how safe this is. And in this case, this is not a problem because the customer filters country region filters budget, and the chain of relationship ends here. Budget is not filtering anything else. Therefore, bidirectional cross filter in this specific case works just fine. And this was a second technique. So we have seen a first technique, increasing the number of rows in the table. We have seen a second technique, creating an intermediate table in order to build the relationship. There is actually a third technique that we can use to create the relationship between the budget and the other tables in the model, which is relying on a weak relationship, or as they call them today, limited relationships. These kind of relationships are able to link tables even though the column that you use to build the relationship is not a key. Allocated budget is not a key in the brand is not a key in the allocated budget table. Brand is not a key in the product table. But if I use a limited relationship, I can build the relationship based on the brand. And to do that, it's enough to take the product brand from here, drop it here, and Power BI gives me the option of creating the relationship with a big warning that says, hey, the relationship has cardinality many to many. This should only be used if it is expected that neither columns contain unique values, and that the significantly different behavior of many-to-many relationship is understood. Now, this measure is basically a warning that is telling me, hey, if you know what you are doing, go ahead, but if you do not, be aware that you might find a lot of troubles. With that said, whenever I see a warning yellow message that I do not completely understand, don't know what you do, but I typically just click on OK and go ahead. So I just click on OK, and the engine created the relationship. Unfortunately, it created the relationship and it is not enabled because it tried to create a bidirectional relationship. That would create ambiguity. When you have limited relationships, you need to choose the cross-filter direction, because when you have a one-to-many relationship, the cross-filter direction is always from the one to the many side. Here, you need to decide whether you want the budget to filter product or product to filter budget. We know we want product to filter budget. And if we make that, we can now create the relationship and make it active because we avoid ambiguity. Now, product is filtering budget through a relationship that you see has the many side on the product and has also the many side on the allocated budget table. Its behavior is nearly the same as the relationship between customer and country region. But I do not have to create the country region table. I can just rely on a limited relationship. Let's see whether it works. Let's get rid of country region, and instead we use the product brand. Where are you, product brand? Here we are. Now I can slice by product brand. I see sales in 2009, the allocated budget, and everything looks like it's working fine. Indeed, it is. if we take the product brand and the customer country region, I don't find customer, okay, country region before, I can slice by country region, I can slice by brand, and I can look at sales in 2009 and the budget side by side. So by creating relationships, we have seen three different ways of creating relationships, and by creating relationship, we now integrated the budget inside the model containing all the sales. We need to go one step further and check that the numbers that we are computing are actually correct, because we might have problems if we do not pay attention to how numbers are computed. So let's see how correct they are. If I slice by country region, it's fine. If I slice by brand, it's fine. If I filter by different scenarios, you see that the budget changes, and again, that is fine. What happens if I go over that? So if instead of limiting myself to use columns which are meaningful for the budget, I use columns that go farther than that. So for example, I can add the color. And I didn't want it on the columns, I want it on the rows. If I expand a datum, you see that now we start to have a problem, because the budget does not show different values for different colors. This is kind of expected, because think about that. The relationship between product and budget is a relationship at the granularity of the brand. That means if I slice by brand, the filter on the brand will go to the allocated budget. But if I further slice by color, this is not affecting the relationship, that still uses the granularity by brand. It is similar to what we did with the data. We linked with the 1st of January. That is, if we slice at the month level, everything will work fine. But if we go at the day level, we will see incorrect results, because all the budget will be allocated on the 1st of January. Here, the budget is allocated at the brand level and not at the product level. This doesn't seem like a big problem, because when you see the same number repeated again and again, you know that something wrong is happening. The engine is not able to compute the correct value. With that said, showing a number which is not correct or which is not sliced correctly is always a problem. It's your responsibility as a DAX developer to make sure that if you show a number, this works correctly. If the filter context has gone too far, so you are filtering by color and your measure does not support filtering by color, then it's your responsibility that of blanking out the measure, providing an error message, do whatever to inform the user that you cannot compute that number. So what we need to do here is avoid repeating this number again and again, and instead show a more meaningful number. Even because right now you see the numbers are all different. But what happens if I remove the brand from here? If brand is no longer part of the equation, now you see that the numbers are all different, which would make a user think that these numbers are indeed correct. Instead, all these numbers are wrong. There is not one of them that is correct. The reason being, the relationship is based on the brand. When you filter by color, the filter on the color results in a cross filter over the brand, and the filter on the brand will go to the allocated budget. So if color is red, brand is showing all the brands that contain at least one product that is red, and the filter over the allocated budget will show the budget of any brand that contains at least one product that is red, which is definitely the wrong value. So we need to fix that. And to fix that, let's go back to the original report that also contained the brand. We need to understand when the filter has gone too far. So I want to show this value because I'm slicing by country region. I want to show this value because I'm slicing by brand. I do not want to show this value because now I'm slicing also by color. Slicing by brand is supported, Slicing by color is not. So you need to write code that understands when slicing has gone too far. There are a lot of different ways you can achieve this goal. One option is to use isFiltered. You can check isFiltered on all the different columns in order to understand which columns are filtered and which columns are not. This would work, but it's incredibly boring to write code that checks isFilter for all these different columns. Instead, what we can do is leverage again DAX and understand by the number of products visible in the current context whether we are slicing at a granularity that is still supported by the budget or we have gone too far. Let's see that with an example. Let me add to this report a simple calculation that is just the number of products. Number of products, which is just a count rows of product. And then I add it to the report. Why is this number useful? Well, this number is useful because it is telling me that when a datum is selected, so when the filter context is filtering a datum, I should see 132 products. If a datum is selected and I see only 14 products, that means I'm not seeing in the current filter context the entire a datum set of products. I'm seeing a subset of it. And if I see a subset of a datum, this means that I cannot show the budget because I'm looking at a smaller number of products and the budget is related to the entire family of a datum products. So I need to check that when a datum is selected, I see 132 products. And when AdventureWorks is selected, I see 192, and so on. For Contoso, it needs to be 710. What I need to do is build another measure that computes 192 here for black, for blue, and for brown, so that I will be able to compare the number of products with the number of products that I should see if I were slicing at the granularity that is supported by my budget. So what I need to do is build a measure that computes 192 here. This measure is not hard to compute. We call it number of products at budget grain. We use calculate, we compute the number of products, and then what we need to do is remove any filter from the product table and keep only the filter on the product brand. We could use all except, but all except would work for the product, but it would not work for the customer. The reason is the difference between using all except or all values. We have a video that explains that, so if you're not sure about that difference, go look at the video, read the article, because it's important to understand when to use all except and when to use all values. In this case, what we need to do is remove any filter from the product and restore only the value of the product brand. This computes the number of budget at the granularity supported by my budget. And if I put it here, you see that I have 132 when I am at the budget grain, but I also have 132 everywhere else, regardless of the filter that I'm placing. And this is not tied in any way to the color. I can get rid of the color from here. Let's get rid of the color, which is here, and instead use the category. The numbers will be different, but still I see 710 everywhere. Now category is a bit too large, so we can get rid of category and put again the color. So we see all the values together. Last step is I need to protect my budget information in order to avoid showing the value if the number of products visible is not the same number as the number of products at the budget granularity. This is just a simple if statement, but here I'm still using the implicit measure allocated budget. You see that I just took allocated budget from here. Instead, I need a measure. So we can build a measure to add our if statement, which we call protected budget, which checks if the number of products is identical to the number of products at budget grain, then it shows the sum of the allocated budget. Otherwise, by default, it does not show anything. We format it as a decimal number with commas. Now, from here, we can get rid of the allocated budget, and instead we put the measure protected budget. See what happens? Now I have the value of the budget when I can show the value and a blank otherwise. It is extremely important that you pay attention to these details because you do not want, I know I'm repeating myself, but you do not want to show wrong values. If the filter context is not what you would expect or what is needed for your formula to work, you need to blank out the measure and say, I don't know how to compute that number. Never show a wrong number. That's a really bad practice. We still need to do that for the customer too. So we need two measures. Let's save some space. Let's get rid of number of products and number of products at budget grain. We have the protected budget. We create a new measure, number of customers, which just count rows of customer. Put it here. We have 5 customers in China and 1791 in Germany. Let me get rid of the color. We don't need that anymore. So 5 customers in China. I need to build another measure. We're using the same pattern that we used earlier. Number of customers at budget grain. Grain. Which uses calculate. Number of customers, we remove the filters from the customer and we restore the filter at the correct granularity, which is the customer country region. And now that I have the two measures, I can go in my allocated budget, protected budget, and check that this is true. And at the same time, the number of customers is identical to the number of customers at budget grain. By writing the code this way, I'm sure that I'm protecting my code from both going too further in the product and also in the country. Let's give that a try. Let me remove the brand. And instead from the customer, we add, for example, the education. We expand Germany. And you see that protected budget does not show anything because number of customers shows a value, but number of customers at budget grain for Germany shows still 1791. So these two numbers are not identical, therefore the measure blanks out the value. So far we have created this report that is able to slice by country region, it slices by brand, and it blanks out the measure if the granularity is not supported. The question is, can we do anything better than that? We have been able to detect when our calculation might fail, but can we actually do some calculations? Instead of blanking out the measure, can we put some reasonable number if the user decides to browse further in the granularity? Actually, it turns out that we can do something better than that. Let me rebuild the original report. I want to slice by country region. I want to slice by brand. So I have China, a datum, and I also want to slice by color. If only I find the color. Now ask yourself, what number should I show here? I don't want to show the value of 171 because we know that would be wrong. But what if I say, well, I don't know what the value should be, but I can assume, as we did with the dates, that the division, the separation, or the division by color, the allocation by color, might be the same that happened in 2009. And I have the sales in 2009. I know that 1 million of sales were of black products. So around 1/5 of the entire sales amount was black. So I can take this number, divided by this number, multiply by that number, and this computes a number that I can put there, which is reasonable. What I need to do is compute the sales in 2009 that I already have, and the only number that I'm missing from the equation is this value computed here. So I want a measure that computes the sales in 2009 at the budget granularity, whatever the filter context is. And the technique is the same that we used in the measure of number of customers at budget grain. This time I will compute the sales amount, remove any filter from product and from customer, and restore the filter at the budget grain. That will give me the denominator to use in the percentage that allocates the budget. We can do that. Let me create a measure that we call sales 2009 at budget grain, which is just calculate sales in 2009. We remove filters from customer, and we restore the filter on the country region. Then we remove the filter from product, and we restore the filter on the product brand. You see, it's the same pattern we used earlier. It's only that now I'm doing that on both tables, both customers and product. We format it as a decimal number. Put it here. And it's just wrong. Why that? Let me see, sales in 2009 at budget grain. Remove filter, values of product brand. That's kind of weird because, I wrote this code a ton of times and I know it works, so that should be something different. The code seems correct. So there should be something different. Let me see. Oh, I see that here. I'm using the brand column from the allocated budget table, so the filtering is going the wrong way. I do not need to use the brand from allocated budget. I need to use the brand from the product table. And now it works. So you see it shows 214, which is the sales in 2009. Now I need to divide this number by this number and multiply by this number. That will provide the correct value for the projected budget. By the way, it's useful that we found that problem because it also shows you that columns that should not be used need to be hidden. We never want to use columns from allocated budget to perform the filtering because otherwise that creates issues that are kind of complex to find. So last step is go to the protected budget. Where are you, protected budget? And all the work that we have done to compute this condition is actually not useful because Now that we know how to allocate budget at the correct level, we can simply divide, well, let's use a variable, percentage, that is the division of sales in 2009 by sales in 2009 at budget grain, budget value, and then we return budget value times the percentage. Actually, instead of returning budget value by percentage, it's useful to return the percentage to see the value. We format it as a percentage. That gives you a better picture. You see that the value we are computing now is just a percentage, and it shows the percentage of the total that we need to allocate row by row. Once we are confident that the number is what we want, we just multiply that by the budget value. And we format again as a decimal number. Now we have the total that is still correct, and we are allocated by color the different values. We can get rid of useless measures like this budget grain. I have my new protected budget that allocates by color, and it allocates by whatever. So from the product, I can get rid of the color. I can add the category, and the allocation is dynamic and it just works. In the case of China A datum, we have only one category and the budget shows the complete value. For Adventure Works, we have 3 categories which are allocated using the sales in the previous year. Now, before we move any further, one important detail is that this measure is still wrong. So do not run and use it in your models because it is still incorrect. Whenever you work at a different granularity, so you have tables that have a link that is not at the key level, you need to pay a lot of attention to the details because calculations can be completed, can be executed, but you always need to go at the correct granularity. You cannot pre-aggregate values and then compute further numbers. Let me explain you that with some numbers or with the aid of some visual. Let's go back to our sales distribution value. The numbers we have used to do the allocation are coming from these cells. Now, this cell, for example, Adventure Works in China, is telling me that Adventure Works in China in January should have 0 as its allocation factor. And if I do the calculation at this grain, I can compute that number. But if I remove the brand, and if I remove the country, let's forget about China, and I use the aggregated values of all the countries together, you see that Adventure Works in China has no sales, in Germany it has no sales, but in the United States, Adventure Works has an amount of sales. If I only take the aggregated value, I will take 259 for Adventure Works across all the countries. And then I will allocate it based on allocate some values also for China. That would be wrong. If you want to do any kind of calculation at the correct granularity, I need to perform the calculation at the grain that is supported. So my measure, my protected budget, where are you, protected budget, cannot be computed that way. I need to make it a bit more complex. What I need to do is force the calculation. Let's do that with another measure. Let me go back here. We have the protected budget. And let's create a new measure, which we call the correct budget. Correct budgets need to iterate over values of product brand, cross-joined with values of customer country region, and then compute this entire calculation for only the combinations that we are currently iterating on. And I bet we also need to keep filters around it, just in case there are some arbitrarily shaped sets that in this case are very, very dangerous. Now, the correct budget does the same calculation that we have seen earlier, so it's the same calculation, but it guarantees that the calculation happens at the granularity of brand and the country region, which is the supported granularity of my budget. Let's format it as a decimal number. We put it here. And numbers are now the same if we slice at the correct granularity, but if I remove China, for example, let me get rid of country region, you see that now the values of the correct budget are slightly different than the value of the protected budget. Protected budget is potentially wrong. Correct budget is the correct one. That's why the best thing that we can do at this point is get rid of protected budget that is showing a wrong number and just look at the correct budget. Let's look again at the code of correct budget. You see that it's iterating over the cross-join of brand and country region to guarantee that the calculation happens at the correct granularity. And finally, it does the calculation using the percentage of the sales in 2009 against the previous year. Now, that was quite a long trip in order to write a complex expression, but the main goal was to show you how you can leverage DAX to compute values which are totally not trivial. And when it comes to budgeting, this is typically the first step, because then you can do further calculations on top of this basic budgeting measure. What I want to show you is the final result. The final result applies further calculations on top of this base formula that was actually the really complex piece of code to compute, for example, the budget year to date, or to show actuals and forecasts at the same time in the same report. So let me find this solution. Now this is the same data model, I only added further calculation. So it has the same sale allocation. I call this time the measure forecast instead of calling protected budget, but it's the same calculation. And if you look at the forecast calculation, it's interesting because what I did was going one step further. I mean, you remember that we spent quite a lot of time creating this calculated table, the allocated budget. Now, if you remember the code of allocated budget, it was this gigantic query that we created in order to multiply by 12 the number of rows in the budget table. The thing is, now that we learn that we can dynamically allocate values, what's the point of allocating them statically? We can also allocate by date using the very same technique that we used for the brand and for the country region. So there was no need to create the table, even though it was useful in the learning process because it was useful as a warm-up to understand all the details. But in a real-world solution, you can get rid of that calculated table and just work with the straight tables. And that's exactly what I did in the final model. The final model contains the budget, and it only contains limited relationships with customer, with date. The relationship is based on a year that only contains 2010, so it is a relationship again at a different granularity, and the third relationship with product, again at a different granularity. The code of the measure is slightly different, but it's just a variation of the original code. It does a cross-join by brand and country region, takes the current brand, the current country, computes the sales in the same period last year, because instead of hard coding 2009, I just take the previous year. the sales in the previous year at the budget granularity by removing filter from product and restoring the one on the brand, removing filter from the customer and restoring the country region, and restoring the full previous year. Then it divides the sales by the sales at the budget grain. This selected scenario is only to provide the default value for the scenario in case the user does not choose one, computes the budget value, and the result is the percentage times the budget value. Everything inside a SUMX that iterates over the table. And now you can compute easily the forecast that slices by year, by month. You can choose one individual category, and all these numbers are correct. What this report does is going one step further. I'm not going to explain you the formulas in this specific report because mainly these formulas are useful to show actuals and forecasts in the same chart, and we already have a video that explains that part of the code. But that video does not explain this formula. So by mixing them together, you will have the full picture of how to compute an allocated budget and also how to show that in the same scenario. So the beauty of this forecast measure is that you can use it to compute the YTD of the forecast. How do I compute the YTD of the forecast? Well, because forecast has been created the correct way, just by touching the correct filter and not messing up with other values. If you want to compute the year-to-date of a forecast, you only need to calculate forecast dates YTD of date. And that just works because the filter context is handled correctly by all the different parts of the code. So I can compute the year-to-date of the forecast, I can compute the remaining forecast, the forecast that remains, and all this goes to the final result that I wanted to show you, that you can create a chart like this that shows the actuals values, the actuals as long as you have actuals, and then the line of the actuals is extended with the forecast. So you can show the actuals up to some point and the forecast for the future, still maintaining the full, maintaining the system that just works with any slicer. So if I filter by any column, here I'm using the category, but I can choose the category, or well, black maybe is not the best choice, black is typically better. I'm filtering by category, by color, and I'm slicing both sales and forecast, and I'm also extending the value of sales with the values of forecast. Now, time to draw some conclusion from the entire session. As you have seen, I have not shown you how to create a budgeting solution. The idea of the entire session is basically food for thoughts. I wanted to show you how you can leverage DAX to compute values that are definitely not trivial. We started with a simple Excel file containing a few numbers, but by manipulating them, by massaging the data, by changing computing percentage, we have been able to create a solution that let me slice budget and sales with any column in the data model. It is true, it is creating numbers out of nowhere. So we do not have a budget for red Contoso products in China, but we can create that number out of thin air. It's not that just we're creating it, we are reasonably creating it. We are using an allocation factor that was decided as the ratio of sales in the previous year against the total sales. In your specific business, you might have the need to use different ratios, different calculations, but the overall logic is still the same. That's why I think it's important to learn the details of DAX, because that gives you a tremendous power and lets you create in a matter of a few hours a budgeting solution that might not be perfect, but it's a good starting point to gather better insights from your data. Enjoy DAX!